All right, this is the Chapter 1 test review videos. We start out here, and we're going to use this graph right here below number 1 for the first 3 problems. And you'll see they're all on this first page together. So question number 1 is actually down here. And it says, what function family does the graph belong to? This is just asking you, do you know the general shape of the graphs? This one is in fact quadratic graph, okay? An exponential graph, remember we learned it looks kind of like an elbow. It will go up forever or it will go down forever. That's just a couple quick examples. Absolute value is that V shape. That's really not a whole lot in Algebra 1 anymore, but we still have it every once in a while. Quadratic's like the one we have above that is U-shaped. In other words, it turns around and goes back down or go back up. And linear is, of course, any other sort of straight line. Okay? This one is a parabola, so it is quadratic. Which of the following describes the behavior of the graph? So we're just looking to see what it's doing from left to right. That's so important to remember that we read these graphs from left to right. Well, as we start on the left edge of this graph, we can see that it is increasing for that segment right there. But then once we get up to this top, or the maximum, we see that it is decreasing the rest of the way down. So from left to right, this graph increases, then decreases. Number 3 says, which of the following pairs is true about this graph? And it says, it is blank and has blank. Here you can start using some of your test-taking skills. Our only 2 options here are continuous and discrete. Well, that's one of the easiest distinctions we have. We can see that this is definitely not a dotted line, meaning it's not discrete, so it is in fact continuous. That means we can get rid of 2 options right there. Next, we have to tackle the second part, and has vertical symmetry or horizontal symmetry. That means, can we draw a line that splits this graph perfectly in half, such that you could fold it over on itself? Well, if we can see that that said line would exactly be right here, right down the middle. This graph then is going to fold from one side to the other exactly onto itself. That's a vertical line. Therefore, our symmetry is vertical. Number 4, which of the following is a function? What we're looking for here is, can it pass the vertical line test? Okay, that means if you draw a vertical line, does it hit the graph twice? Every function should only hit once. So one of these graphs is also going to just not be like the other ones. Let's start with number 2 for good reasons, because A is actually the answer. If we draw a vertical line, we see that it plops and hits our graph twice. That means this is not a function. C looks a little bit strange. It's actually a sideways parabola. That's what I graphed here that goes way out to the side. But we can see that if we draw a vertical line, it's going to hit our graph twice. No matter where we draw that vertical line, it's going to hit multiple times. D is the tricky one. Most people can get this down between between A and D. They can get it down to those 2 options. Now, D is a vertical line. And if I draw a vertical horizontal line on this exact spot, it actually hits the graph an infinite amount of times. It's always hitting it. Okay, always, always, always. Well, anything that hits more than once is not a function. So when it hits an infinite amount of times, it is clearly not a function. I purposely, because this is an easy question, made option A look very similar. But if you look closely, you can see that option A actually has a slight slope to it. Actually, it's a very high slope, very steep slope. But it does, in fact, have a slope to it, which means even though it doesn't look quite like it, if we draw a perfect vertical line, it's actually only going to hit at one spot. The rest of the way, and I did not draw a very good vertical line, but the rest of the way, it's going to slowly but surely get away from our original graph. Therefore, A is a function. Really, you could just eliminate B and C off the get-go, and then you're down to a 50-50 shot. 5 is a really important question. It's this real-world modeling. And it says, which graph models situation? A child starts with $50 in savings and adds his allowance of $5 to it every week. That means we start at 50. And after 1 week, we're going to add 5 to that, which means we're at 55. After 2 weeks, we're going to add 5, which means we're at 60. essentially what you can see is that we're actually breaking this down as a constant rate of change, as a slope of $5. Every week, it goes up by 5. Well, this is not what option A shows. Option A is curving up and it's getting higher and higher, faster and faster. It's not that. Similarly, we can go ahead and eliminate option D. Option D does not represent our constant rate of change. So we're looking for a linear function, and we have those in B and C. And then you look and go, oh gosh, they're the same thing. Not quite. Notice the starting point. 0 and what looks like 50. How do we choose between them? We go back to the original problem. We see that it says it starts with $50. That's an initial value. Okay? Which means we have to start our graph off at this point, C. Okay? This starting value is what makes it the correct answer. 6 and 7, which is a constant function. Now, you should know this just by looking at the equations, but I had a lot of people today that were asking about how to graph and blah, blah, blah. This you should know is an exponential function because there's an x in the exponent. This you should know is quadratic because it has a squared term. This one, the third one, has a boring x. It's got nothing special going on, but it does have an x, which means it's linear. Which leaves us with our very final answer, and the correct answer, which is D, of it being a constant function. If, let's say, tomorrow you get onto the test and you've completely blanked on that and have forgotten, here's a quick tutorial for those of you that tune into this on how to graph things on the calculator. Okay? First, you open up your calculator and you press the Y equals button. And we'll bring up a list. You can graph all sorts of different things in here. I would suggest graphing one at a time. You can do multiples, and we'll do that later in the year, but I would just start off by graphing one at a time to keep it simple. Our first one is 3 times 4. To get to the exponent, we press the caret button. And then we actually want the variable x to pop up this time. You don't want to do that on the home screen, but when you're graphing, it's okay. Okay? Next, we want to hit second graph. I'm sorry, we want to hit graph. Second graph does table. We want to just hit graph. And we can see that exponential function that I already said that it was. Okay? Now, here is an issue. Let's say your window is really messed up. Let's say whenever you go and graph, you get something crazy like this. Or let's say maybe you get something crazy like this and you can't see what's going on. You're like, oh gosh, my graph didn't turn up. That's going to happen to some of you tomorrow on the test. How you fix that is you press zoom, and then you'll see number 6 right here says standard. Okay, zoom 6 will start you back on a 10 by 10 window. So there's our exponential. We wanted constant, so it's not that one. Again, you could graph this second one. It will come out as a quadratic. You know that's not constant. And then the third one would come out as a linear function, which is also not constant. The only constant function is number 6. Okay? Describe if the function has an absolute minimum, maximum, or both, or neither. So, again, you should know just by looking at it. Okay? You should know just by looking at it that this is in fact a quadratic. However, you do need to break the calculator out for this one. Okay? This is a calculator problem because I don't know if it's a min or max. You can figure that out if you know how to graph it or if you know your rules with your negatives, but better safe than sorry, let's graph it. -3 plus x, quantity squared. So we go into our graph mode, clear out whatever was there. -3, I believe it was plus x, it is, plus x, quantity squared. Oops. Accidentally hit that button twice. Delete that. Okay. Quantity squared. And then -1. Now when we hit graph, we see that it in fact has a minimum. So your answer was minimum.